distribution. Here as well. It's almost Gaussian. That's why you got the median and mean values nearby. They are almost close by. Where will be? Here. This though we can, for the time being, we can leave it. Now, one more useful function that pandas provide is this describe function. What this describe function does is it provides you the mean, standard deviation, minimum, all the 5-number summary in a single go. So you don't have to code every single line, or you don't have to find the min, max, and all the quartiles separately. If you use this describe function, it will give you these values in a single go. Okay, you can see it lets you know the count. You have 150 samples, right? These are the mean values for all the attributes. You have the standard deviation value as well, minimum value. The Q1, 25th percentile is your first quartile, right? Q1, this is your median, 50% is your median, second quartile, 75th percentile, the third quartile, and the maximum value. So if you wish to have all these values in a single go, you have this very useful function described here. Now, suppose, since we have already seen that the distribution follows Gaussian, almost Gaussian, right? So it would be interesting to look at the skewness and kurtosis value here, isn't it? So here you have these functions, skew and kurt, we have already seen. So if you run it, it will provide you the skewness and kurtosis values for all these attributes. That's a bit.
Excuse me, ma'am.
Yeah.
Ma'am, in that describe function, can't we put the variance, because there is no variance. If we want to put variance, so how we can do it directly?
Okay. If you wish to put the variance, then you have to go to that master file. You will have to go to master file and make the changes there. So,
okay, ma'am.
Or else you can research. Maybe it has option.
Okay, ma'am.
If you go to Anaconda website, or you can just Google it, describe panda. So it will tell you if you have some option to look at variance also. It may not be necessary because you have standard deviation here. No? Variance is just the square of it.
Okay, ma'am. Thank you, ma'am.
You check it out. If the option is there, you can use it. Otherwise, it is not necessary. It will almost be redundant. Okay, yesterday I had asked the question, if we already have variance, why do we need standard deviation? Could you find the reason? Anybody? Anyways, if you get the reasoning, let me know. So here we have, yes. Okay, so you have this skewness. The first two values are the skewness, and the second is, oh no, wait. This only shows the kurtosis values. Show only the last line, the value for the last line. Now you have the upper 4 values are the skewness for all the attributes, and the lower 4 values are kurtosis values for all the attributes. So they are almost right. and it is confirmed that the distribution follows almost Gaussian. You have one more useful function here, is null function. Now, is null function will let you know whether any column or data set has null value. Now, since all the values are 0, this means the columns, none of the columns have null values. So nothing to worry. All the columns have some meaningful values in it. If you have null values, so it will show here. Okay? So IRIS is considered a good data set for beginners. Why? Because it is beautifully balanced. It does not have much issues to tackle. You can see there are no null values. This value count we have already seen. So we can skip. Yeah, next. Let us look at some plots, some interesting plots here. This SNS is, do you remember? SNS is the seaborn that I had imported. Here, this one. Seaborn is also a plotting library. So I have imported seaborn as SNS to here. See, this count plot is the plotting function that the seaborn provides. A count plot will show you the count value in the form of bar graph. Now for species, if you need to see, you have to state that the x-axis has to show the species and the y-axis will show you the count for all the species. And the data that you have to take is from IRIS. So if you plot it, you get this. So when you plot it, it becomes visually appealing, right? And gives information on a palette. So Iris setosa, you have 15 numbers. This species also 15 numbers. Virginica also 15 numbers. So as to be a good storyteller as a data scientist, you have to have good grip over the visualization part as well. So this is your count plot. Next plot that you have is a scatter plot. One more useful plot. Suppose I need to look for the relation between sepal length and sepal width for all the species. You will specify X sepal length, Y sepal width, and the species will be described with colors. Okay? Your data is your IRIS data set. If you run it, you have this distribution. Now you must have the idea, right? Scatter plot means it gives a view of how the data is spread. All the data are plotted and is shown using the points. So that is why the name scatter plot. If you look at this scatter plot, it gives you some idea, no? Like this blue one. Blue one corresponds to setosa, species setosa, right? Now all these blue ones are concentrated in this portion. That means for species setosa, the sepal length always means most of the time it is less than 6. It's seen, right? It is clearly visible. And for the same setosa, the sepal width ranges from 2 to 4.5. See? Beautifully it is. Same way for just concentrate on these orange dots. For versicolor, the sepal length ranges from 5, about 5 to about 7. Gives you a very good idea the attributes, the range of it. For some observations I have listed here. Setosa, it has a small sepal length, right? Of all the three species, it is only the setosa that has the smallest sepal length. Sepal length is smaller, it is bigger, right? The blue one reaches the highest now for Y value. So it has larger sepal width. That way you can make several observations. So a scatter plot is a beautiful plot. Most of the time you will have to do scatter plot for data. It gives you a very good visualization of the range. The same thing if you will go for petal length and petal width. See what you get. The scatter plot for petal length and petal width. See? Isn't it beautiful? It clearly shows setosa has small petal length and small petal width. Whereas for versicolor, the petal length and petal width are medium, right? And for virginica, both sepal length and petal length and petal width are larger compared to the other two. So this is how you can see which feature to use so as to distinguish between the species. So petal length looks like a good attribute, right? If you will concentrate on the petal length, maybe you can always predict that corresponding to this measurement, which species is there. So if you are provided that the petal length and petal width are in between 1 and 2 and 0 and 1, so you can predict, no? It must be setosa. If the petal length and petal width, if petal length is between 3 and 5, petal width is between 0.5 and 2. So we can predict it might be versicolor. If the petal length is greater than 5, petal width is greater than 2, we can predict that it might be virginica. So that is how scatter plot helps you. It's a very beautiful. Next, one more plot you have is pair plot. It's pair plot. Okay? We have already dropped this iris. Oh, sorry, icon. Drop it again. Where is the error? Error. Oh. This is your pair plot. Okay. So pair plot means gives you the scatter plot for each pair. Okay. On the horizontal axis, on the vertical axis, you will have all the attributes mentioned. And for all the pairs, you will get to see the scatter plot. So if you need to look for the scatter plot pairwise, then you have this pair plot option. It's a very good option. So if you look at this plot again, see petal length here. Petal length looks like a very good attribute, right? Because for petal length, all the three species are almost distinguishable, right? There is less overlapping between them. Same happens for petal width, right? For petal width also, see the distributions are almost non-overlapping. Whereas sepal width and sepal length they are not very good attributes, because with the help of them, with the help of the information about sepal length and sepal width, we won't be able to predict which species is at our hand, because their distributions are very much overlapping. No? And you have these scatter plots here. This one. This though we have already seen, right? Individually here. So this is your pair plot. A histogram too we have seen already. You have one more option of plotting histograms of all the species together in a single plot this way. Okay, this is your hist function, and you have to list out all the attributes here. Iris dot sepal length means you are extracting the sepal length column here. Sepal width extracted, petal length, petal. So this has to be petal width. And if you wish to use the legend function, then you will have to label. You have to label the corresponding columns. Now, where this label comes from means this label actually contains the names of the columns. Okay, somewhere here. Where is it? Gir jayega beta. I had extracted the names of the columns somewhere. No, where is it? Did I? No. Oh, here it is. Yes, iris dot columns. If you use this column function, just a minute. Now, iris dot columns. If you run this function, it will actually list out the names of the columns here. Okay, yeah, it's a vector that contains the names of the columns. So if you will write calls 0, that means you are targeting this one, sepal length. It is in the 0th position, right? It's in the first position. It is sepal width. So it is calls 1, 2, and 3. So you are extracting the names of the labels here. And use the legend function. Then you will get to see this legend labeling here. So if you wish to have the histogram function as a comparable histogram function, histogram plot, so you can use hist function and list out all the attributes in here. This is another plot that the C1 function provides. It is hist plot. Okay. So this first plot. What is this first plot for? It plots the histogram for sepal length of all the 3 species. The blue one corresponds to the setosa. The orange one corresponds to versicolor, and the green one. It is the same as this one. No? We have already seen in this pair plot, right? This one, these things. So suppose if you wish to look at only these plots, only these histogram plots or these distribution plots, then you have this function, hist plot. Okay. So if you just use hist plot, you will get to see the comparable histogram plots. And these KDE equals to true means it smooths out the distribution. for all the 4 attributes, sepal length, sepal width, petal length, petal width, the histogram plot is made here. So depending upon these observations, you can list out few important points. What I will suggest is, I will provide you the link, or you can yourself go to kaggle.com and you can search for iris dataset and try to do some analysis on your own. This is very primitive analysis. A data scientist spends almost 60 to 70% of his time over analyzing the data this way. Now this action, what we are right now doing, is actually called exploratory data analysis. We are actually doing exploratory data analysis of iris dataset. You can keep this term in mind. EDA, exploratory data analysis. Yes, one more function of importance, this correlation function. If you wish to see how related different attributes are, then you have this function, correlation function, CORR, okay, that the Panda provides, correlation function. So iris.core, if you do iris.core, it will list out in the tabular format the correlation coefficient values for all the pairs. Okay, do you have the idea what these correlation values indicate? Correlation values actually indicates how related the attributes are. If the correlation value nears 1, that means they are very related. Okay, meaning if one attribute is increasing, the other is also increasing. It indicates this relationship. So if you look at this value, this is 0.87, right? Between petal length and sepal length. So it indicates that if sepal length increases, if sepal length is large for some species, there is high chance that the petal length will also be large. Or if the sepal length is small, the petal length will also be small. That kind of relation. So it shows that sepal length is positively correlated with petal length and petal width, right? Yeah, sepal length positively correlated with petal length, petal width. There is one more value here which shows much higher correlation. This one, 0.96. It is between petal width and petal length. So if petal width is small, so petal length is also small. That too we have seen, na? Small petal width and small petal length for the first species. What was the name? Setosa, right? We've already seen. So it is also reflected again here in terms of correlation. Now, if you wish to look at this correlation value in the form of a plot, then you have this option, heat map. You just have to input this correlation, this whole thing. You just give this as input to the heat map function. Okay, here. So it will directly give you the map. So heat map function means it gives you in the form of a matrix the different correlation values. The intensity being denoted or shown by the colors. So this is your exploratory data analysis for the iris data set. There is much more to it, but for the beginning, it is just very good to start with. Up to this is, we'll have many more issues that we will see in the coming classes. Up to this, do you have any doubt? Anybody, any doubt up to this? Hello.
Hello team, please respond to the madam.
No doubt, ma'am.
No doubt, ma'am.
Okay.
No doubt, ma'am.
Okay. Then let me wrap up the session for today. So in a way, you have done exploratory data analysis. So at least one step we have covered. Obviously, there is much more to it. We'll see it in the next class, in the next coming classes. Okay. Okay, sir. So we can end the session.
Okay. Thank you, madam, for valuable session you did.